I don't hear any music though.
Unfortunately, it wasn't played too soon.
All right.
The other things.
So all the people who are streaming are having a better experience than people who are joining. Oh,
That's
wow.
the truth. That's the truth.
That's the truth. That's the cat right there.
Hi, Kiki. Oh, I love that cat. It's the best.
Did we name it yet? We didn't. We haven't.
We have not named it yet. We have not named it yet.
Hello, everybody. Welcome to OpenCV weekly webinar. And today we have two guests with us. Devang Agarwal, he's the tech product manager at OpenVINO, and Preeta Veeramalai, who is the AI framework engineer at OpenVINO. And I'm sorry if I actually mispronounced your name, Preeta. Even though I'm from India, there are several parts of India, you can slightly
really takes the pressure off me, Satya.
Welcome both of you. Also with us is Phil Nelson, who is the director of content and creative at OpenCV, and he is responsible for putting this show together, among other things. So welcome, Phil. And once you have given the brief introduction and also how the webinar goes, how we progress with the webinar, we'll go to Devang and Preeta so that they can introduce themselves.
Yeah, hey everybody, good morning. We are sitting in the tall cotton today, rest in peace Vince Scully, with another edition of OpenCV Weekly Webinar. I am the co-host with the co-most, Phil Nelson, the second banana who is second to none, your plus one and only. And I'm here to remind you of a few things that we do every single week here on OpenCV Weekly Webinar, the first of which is a special giveaway to one lucky viewer in the audience. If you're in the Zoom chat, you can win a OpenCV course of your choosing at the end of the episode. If you're not in Zoom, you can join by going to opencv.live. We're also taking Q&A from you in the audience, so use the little Zoom Q&A button if you're in Zoom, or ask your question in the chat of wherever you're watching the show, YouTube, LinkedIn, everywhere. That's about it. Satya.
Yeah, so today, our talk is about OpenVINO execution provider for ONNX or ONNX. I'm always confused which is the right one. A lot of people use ONNX. I personally use the phrase ONNX. Others use ONNX. So the debate is
it's tough
raging
to know sometimes.
But let me give the stage to Devang and Preeta and let them present how OpenVINO helps us with the ONNX runtime.
Welcome, folks.
Thanks a lot, Phil and Satya. Super happy to be here. Super excited to be here. Thank you for the great introduction, and looking forward to share and have the session about OpenVINO execution provider for ONNX runtime.
Thanks for the cool introduction. Yeah, you did pronounce the name right. Almost. It's Preeta Veeramalai, joining from India.
Awesome.
Looking forward to the cool session.
Awesome. Thank you so much, everyone, for joining today. So today's session is going to be an introduction to OpenVINO execution provider for ONNX runtime. I'm Devang, right? I'm a technical product manager, part of the OpenVINO organization at Intel. I'm joined here by Preeta Veeramalai. She's an AI framework engineer, part of the OpenVINO execution provider team. She's been working on OpenVINO execution provider for ONNX runtime for quite a bit of time. And the tagline for this product is we can accelerate performance for ONNX models on Intel hardware with just minimal effort required on your end, right? And you'll see how easy it is to install and use this product, right? And I hope by the end of the session, you guys will all give it a try, and you guys will be inspired to use this and see yourself, right? How good of a performance boost you can get using this product.
Yeah.
So what's on the agenda today, right? So basically, we're going to start off by giving you kind of a quick thing on why deep learning, right? Why is deep learning so prevalent globally right now? And what are some of the challenges we see in deep learning, right? We're going to kind of dive deep into what are some of the challenges we really see in deep learning. And then we introduce you to this powerful toolkit called OpenVINO, which is basically solving essentially a lot of the challenges that we see in deep learning as a whole, right? And then we'll we'll give you an introduction to what is ONNX and one is ONNX Runtime. And essentially, this will lay the platform for you actually understanding what exactly OpenVINO execution provider for ONNX Runtime is. So once you have the background and about all these three products, OpenVINO execution provider for ONNX Runtime will give you an overview. You'll understand what exactly this product does, and then we'll tell you how to get started with this product, right? How you can install it onto your machines, and how you can how it actually works, right? And how you can kind of integrate it into your ONNX applications, right? And then after that, we'll dive into some of the demos that we have. We have some very cool and exciting demos that Preeta will be sharing. There will be showing the performance boost that you can get with OpenVINO execution provider for ONNX Runtime. And then we'll show you some of the cool and exciting features that we have as part of this product, right? What is the feature set for this product, essentially? And then finally, I'm going to give you a sneak peek into what's next, right? And what is like a product that we've just recently launched, and it's in beta preview right now. And I want to give you a sneak peek into that. And this product is catered for PyTorch developers. And I won't give too much details into it right now. I'll let that. We'll keep it till the end of the session. And I bet you guys will love it. Awesome.
So I really like how you have laid down, this presentation will work even for people who are beginners and they are starting. And the way I think about OpenVINO, it's a free lunch that you get in deep learning, that you build your own model, and then just like that, you run it through OpenVINO, and suddenly you have this 3x boost in performance with almost negligible, loss of accuracy. So, and now we'll see how it works with the ONNX runtime, and we'll explain all these terms in detail as we go through the presentation. So if you don't understand what is OpenVINO, ONNX runtime, etc., don't worry about it. We'll come to it and explain each of these terms.
Thank you, Satya. Sure.
Sounds great, but what's an agenda? I'm kidding.
Good one, Phil. So let's first dive into why deep learning, right? Why exactly is deep learning so powerful right now, right? So the need for AI on edge devices has been realized, and the race to design edge optimized chipsets have begun, right? According to research from Omdia, the global edge AI chipset revenue will reach $51.9 billion by 2025, driven by the increasing need for AI inferencing at the edge. And particularly, AI processing on the edge circumvents privacy concerns while avoiding the bandwidth, latency, and cost concerns for cloud computing. So essentially, there is tremendous opportunity in the global growth in chipset revenue driven by AI inference. So how do you determine the right computing for your AI needs, right? It starts with taking a cross-section of your environment to determine the breakdown of AI and other workloads, right? That's the first thing that we're kind of looking into. Next, we figure out what your user and or use case requirements are, right? These may include factors like throughput, accuracy, response time, cost, size, power, data size, security, manageability, reliability, and much, much more, right? And then finally, determine how much demand there is for AI in your environment, right? What percentage of your overall compute is running AI? Is AI persistently in use, right? What kind of scale is required for AI workloads? And once you have answers to all these questions, right, the challenge of identifying the right AI compute to meet your needs and keep TCO low becomes a lot more manageable. So, what are some of the some of the challenges we see now in deep learning, right? Development and deployment challenges. There are. I mean, even though deep learning there are so many breakthroughs. We're seeing so many new opportunities coming that deep learning enables. There are still very, very little deployments today. So, essentially, the three main challenges we're seeing in deep learning are, there are unique inference needs. There are challenges in integration, and no one size fits all, right? So when we look into, what is exactly this, like the challenge with the unique inference needs, basically when you're deploying deep learning networks from training environments, typically in data centers or server farms to real world production use cases, it's very challenging. It can be very challenging, right? There's a significant gap in performance and accuracy seen in trained models compared to what gets deployed in the field. So there are unique sets of technical challenges that come into play when it comes to deployment. When it comes to integration challenges, right, typically the training of the deep learning networks is performed in data centers or server farms, while the inference might take place on embedded platforms optimized for performance and power consumption. So there's a disconnect in the end-to-end development workflow. So from a software perspective, there are various programming languages, third-party dependencies, memory consumption, and supported operating systems. From a hardware perspective, there are different data types, limited power envelope, and form factor constraints. So there's a need for a dedicated API or a communication link between the software and hardware. And of course, like no one size fits all, right? So there are diverse requirements for myriads of use cases that require unique approaches. So for every problem, there could be a unique combination of networks, models, and target devices.
And sometimes the same model is also deployed to several target devices.
Exactly.
Right? So that's another variation of it.
Exactly. So now that we know, we see the challenges in deep learning, right? And we see what are some of the challenges we've seen, right? Now comes in this powerful toolkit that Intel brings to you, which is called OpenVINO toolkit, right? And this is out here challenging a lot of problems that we are seeing in deep learning. So the Intel distribution of OpenVINO toolkit is actually a tool suite for high-performance deep learning targeted faster, more accurate real-world results deployed into production across Intel architecture from edge to cloud. And it enables high-performing applications and algorithms to be deployed in the real world. So in addition, the path to inferencing is simplified with a streamlined development workflow. With a write once, deploy anywhere approach, developers can write an application algorithm once and deploy it across Intel architecture, including CPU, iGPU, Movidius VPU, and GNA.
For people who do not know, could you explain the various things? CPU, GPU, people understand. iGPU stands for integrated GPU. You mentioned VPU, which is basically the MyriadX.
Exactly.
Are there other VPUs or
visual processing unit, right?
Yeah,
yes,
Kimbe is
right.
another one.
Kimbe is also, yeah.
That's another VPU.
Yes, right. So that's also Kimbe is coming out. Kimbe is there, and we are right now, like OpenVINO currently doesn't have full-blown support for VPUX right now, which is called VPUX, which is Kimbe. Right now, it's kind of in beta, but we are going towards that as well. That's another sort of thing that we are looking towards. So yeah, that's right. Kimbe is also like something that's at least on the roadmap for us to at least have like have that enabled on VPUX as well, which is Kimbe.
Okay, and GNA?
Yeah, so GNA is basically like another sort of like hardware type that's there. So that's what OpenVINO has done from our side. Like from our side, we haven't really enabled our products on GNA, but OpenVINO has been on GNA.
Okay. Sure would love to get my hands on one of those Kimbes.
Well, OpenCV AI Kit, the Pro version, OGD Pro, will be based on Kimbe starting the end of this year.
Ooh,
so wow. Yeah, so it's basically OGD Pro right now, but with 5x processing power. And Kimbe also has a built-in CPU, which is based on ARM architecture. So in addition to the all the deep learning based shapes that they have, in addition to that, they also have a CPU which is ARM based. So you have additional processing power, but the GPUs themselves, the product itself is at least 5x faster than MyriadX, right? Wow. So I'm very excited to try it out. I don't have a device in my hands right now, but it's coming by the end of this year.
So now that we know more about OpenVINO toolkit, right? Why OpenVINO toolkit, right? And this OpenVINO is very valuable across many key industries, right? From industrial and health and life sciences to retail, safety and security. OpenVINO can help with any of the use cases, right? It can help enable safe, smart, and efficient industrial applications. It can support improved patient care and enhance medical diagnosis, right? You can create more personalized, more convenient experiences. And it can also maybe help improve public safety with deep learning, right? So whatever your use cases across many of these key industries, right? There's a chance that OpenVINO can be very valuable in this case, right? Where we are seeing like accelerated performance of some of these use cases that we're seeing.
Yeah, there's a lot of content to digest on that slide.
Yeah. So
well, we can just do a quick summary before we go to ONNX. So whenever you are building an AI model, usually you would use frameworks like PyTorch, TensorFlow, Caffe to some extent. Now it's fading away. But let's say PyTorch and TensorFlow are the main ones that you would use to build a model. And once you have built the model, you have to optimize it for devices like this OpenCV AI kit, right? These are edge devices. And for the model to work on this thing, you can obviously use a model that is directly, trained. But to get the most optimized performance out of it, 3x, 4x more performance, you have to actually convert it to something which is more efficient, right? And also the same model could use different parts of, let's say it's working on a CPU, but depending on the number of cores of the CPU, it would use a different kind of optimization. The CPU itself may have certain, the architecture itself may provide certain optimizations that will help you speed up things. So that is CPU. Let's say you are on a GPU. On a GPU, you may have special deep learning, processors for deep learning. Let's say a 16-bit processor. So OpenVINO would automatically convert your model to use 16 bits instead of 32 bits or 64 bits, and so it would be optimized for the GPU in that case, right? Similarly with the VPU, there are all these different optimizations that you can use with OpenVINO that make it specific for the hardware. These models get optimized for the hardware, even though when you were training the model, you did not know anything, you did not care anything about the exact hardware it is going to be deployed on. So that's where OpenVINO comes in. Now let's learn about what is ONNX runtime.
Awesome. Yeah, very well said. Thank you, Satya, for giving that summary. So now that we know, now we have a good picture of what OpenVINO Toolkit does, right? For us to dive into what exactly OpenVINO execution provider for ONNX runtime is, we need to really understand what is ONNX and what is ONNX runtime, right? So over here, as you can see, what is ONNX, right? ONNX is an open format built to represent machine learning models, right? So it defines a common set of operators, and these operators are essentially the building blocks of machine learning and deep learning models. And there's a common file format to enable AI developers to use models with a variety of frameworks, tools, runtimes, and compilers, right? So you can develop in your preferred framework without worrying about downstream inferencing implications. So ONNX enables you to use your preferred framework with your chosen inference, right? So you can convert TensorFlow, PyTorch, Caffe, MXNet, and many more models to ONNX. And there's a massive model catalog in ONNX Model Zoo, right? So ONNX Model Zoo, you'll see models from image classification models to object detection models to NLP models, right? There are a wide range of models over there, right? So, and whatever your use case is, ONNX models are there to help, right? You can venture out to the ONNX Model Zoo. You'll see these pre-trained models that are already there. Suppose you have a classification use case, you can try out an ONNX model that is catered towards classification. If it's for detection, you can use an ONNX model that's catered for detection. Or if you have an NLP use case, right, you can use something from the ONNX Model Zoo as well. So that's essentially what exactly ONNX is.
Yeah, and if you want an analogy for that, right? Let's say you want to build a spreadsheet. You can use Excel to do it. You could use numbers from Mac to do it. And they will store the data in many different formats, right? And to make sure that, and maybe, it's not very easy to read those formats. Sometimes they are proprietary formats. But if you write things in CSV format, if you're a converter which converts everything to CSV, then for tabular data, no matter whether you have produced this in Excel or numbers or anything else, you can convert this thing to an open format that everybody understands, and then you can use that data. Similarly for models, right, even though they might have been, the model could have been produced in TensorFlow or PyTorch, these are not closed formats. These are open formats. Still, they are not consistent formats, right? You cannot take a PyTorch model and make it work on TensorFlow out of the box. TensorFlow will not read a PyTorch model. And for that, you have this intermediate model that is open. Everybody has agreed how the various layers would be represented. So no matter whether you produce the model in TensorFlow or PyTorch, you can convert them both to ONNX and then read them both using the ONNX format. So that's where the idea of ONNX came into being. That it's multiple companies collaborating to work on the standard so that you can share models easily, even if you're using different tools.
Yeah, perfect.
Yeah, and I think it represents one of the 3 traits of the virtuous programmer, which is laziness. You get tired of writing these custom importers and converters, and so why can't we just all agree on one?
Right.
Yeah. So now that we know about ONNX, right? We have an overview of what exactly ONNX is. Now let's learn more about ONNX Runtime, right? So ONNX Runtime is an open source project hosted by Microsoft. That is designed to accelerate machine learning across a wide range of frameworks, operating systems, and hardware platforms. So it enables acceleration of machine learning inferencing across all of your deployment targets, such as using a single set of API. So ONNX Runtime automatically parses through your model to identify optimization opportunities and provides access to the best hardware acceleration available. So you can run inferencing of converted ONNX models from frameworks like PyTorch, TensorFlow, Keras, through ONNX Runtime on CPU, GPU, FPGA, and NPU. So now that you know about OpenVINO toolkit, you know about ONNX, and you have a high-level overview of ONNX Runtime, right? Now I feel like you will be able to understand how we have joined hands with Microsoft and integrated OpenVINO toolkit into the ONNX Runtime framework. So now I'll hand over the mic to Preeta, who will give an overview of OpenVINO execution provider for ONNX Runtime.
Good job, Deval. Preeta, the show is yours.
Thanks, Devang, for the cool presentation. So now let's look at what is OpenVINO execution provider for ONNX Runtime. Basically, OpenVINO EP, short form for ONNX execution provider, utilizes the power of OpenVINO toolkit through the ONNX runtime to accelerate the inference of ONNX models on Intel CPUs, Intel integrated GPUs, and VPUs. It facilitates the user to run inferencing of ONNX models using ONNX runtime APIs, while OpenVINO toolkit as a backend at ease. So they don't need to learn any new APIs to enable the OpenVINO toolkit. They can be very comfortable with their ONNX runtime APIs. So now let's have a quick overview of the architecture of OpenVINO EP for ONNX runtime. So if you look over the left, we have an ONNX model which is coming into the ONNX runtime application. Initially, it is converted into an in-graph memory representation. So, and then it goes into the graph partitioner or a Git capability module. So this is the key module that queries all the backends that's available in the device, and it asks which part of the graph it can support, so that the providers that we have enabled can reply based on their operator support status and say that these are the subgraphs that we support and these are the operators that needs handles back to the ONNX runtime. So we know that OpenVINO is a generic toolkit that can have its own like kernels defined. So there might be a few operators that may not be supported at OpenVINO toolkit, but that is handled here at the graph partitioner, which can like select the subgraphs or the portions of the graph that is supported at OpenVINO and executed it on the OpenVINO toolkit, whereas having the unsupported operators run on the native ONNX runtime framework.
So Preeta, can I just interrupt just slightly so that, this is all new to me as well, so that I can also...
Sure.
We're all learning a lot today.
Yeah. So,
Sure.
So for OpenVINO, let's say we did not have ONNX in the scene, right? Then you would convert a model to OpenVINO format, and then there is the OpenVINO runtime, which will actually do the execution, right, on the device.
That's right.
And similarly, ONNX also has a runtime to run the ONNX model, right? For all the devices, you would typically use ONNX runtime to run an ONNX model, and it would, based on CPU, GPU, etc., it would do the job for you. Now, this OpenVINO, now this integration with OpenVINO, etc., it looks like, and correct me if I'm wrong, you have the ONNX runtime, but some parts of that, when it decides, the ONNX runtime decides how to execute this model on a particular device. In that case, parts of that thing are being taken over by OpenVINO runtime, whichever it can do efficiently. And there could still be some parts which OpenVINO doesn't handle, and ONNX would handle it for us. So it will use a combination of OpenVINO in the backend. ONNX runtime would use OpenVINO in the backend for part of the execution, and for the other part, it would use its native execution. Is that about right?
It's actually not the ONNX runtime that decides. So consider I'm a user and I have an Intel device. I want my model to be inferenced at whatever highest efficiency that can be possible for my Intel device. So that's where OpenVINO toolkit comes into picture. So it has its own optimized libraries that can efficiently run the deep learning models on my Intel devices, right? So when I have an Intel device at place, I will say use the OpenVINO execution provider for me to run the inference. Okay. So when we enable this OpenVINO execution provider, the priority will go to my OpenVINO toolkit. So I have this capability which will actually select whether the operators in the particular model, right? So we have a model is nothing but a group of operators, mathematical operators that combine together give us a classification or object detection, whatever the purpose it may serve, right?
Or as Elon Musk says that all of machine learning is 99% dot products. So
that's right.
So it's a bunch of operators.
That's right. Yeah. So
or
based
on
this
if statements, as some people like to say.
I don't go with that, but anyways, this is a bunch of operators, pretty all connected together. And this graph partitioner, it intelligently says, okay, you have these many operators in your graph, and I can support these many in the OpenVINO inference. Most cases, almost the entire graph would be supported, and in some where there are still new operators coming in every day, and then there is new frameworks they are getting enhanced, right? So a lot of picture comes into place, and then for OpenVINO, there might be still some operators that are not supported. And those operators, those will be run on the native ONNX runtime framework backend.
Okay, sounds good. Yes, please continue.
So what happens is when it's time for the ONNX model to be executed, this ONNX runtime will send the supported subgraphs to the execution provider, and it will do the inferencing for the rest of the models. Basically, throughout, there will be a serial communication between the ONNX runtime backend and the execution provider seamlessly, where the user can only see the model's output at the result of execution. So all this happens internally, so the user can enjoy the privilege of OpenVINO execution provider using the native ONNX runtime APIs. Yeah, so Devang will go through the APIs.
Sure. Yeah, thanks a lot, Rita. Thanks a lot, Rita. So so now we'll talk about how you can get started with OpenVINO execution provider for ONNX runtime, right? Now you have a better understanding of what this exactly does. But now we'll talk about how you can install this onto your machine, right? So the three options that are given to you is one is build from source. There's a Docker image, and then a simple pip install, right? So all our code is hosted in Microsoft's ONNX runtime GitHub repository. Like I mentioned before, right, Intel and Microsoft have joined hands to create this product, right? So basically all our code is hosted in their GitHub repo, and it's fully open source. So users can just build from source and get full access to our C++, C#, and Python APIs. You can also head over to Docker Hub and pull the Docker image onto your Linux machines and get access to Python APIs. And then, you can also just simply pip install the ONNX runtime-OpenVINO package, which is hosted on PyPy. And I would suggest, if you're a Python developer, easiest way for you to get this onto your machine is the pip install, and that's very seamless and very quick to install it onto your machine. And if you have your phones handy throughout this session, right, just scan these QR codes while we're talking, and we're talking to you and giving you this overview, right? Scan the QR codes, go through some of the material that we have over here, and you can, give it a shot, right, and try it out yourself and while we are presenting. And if you have any questions, just feel free to kind of post it in the comments. So now that we know how we install, right, how we can install this product, this solution onto your machine. Now let's just learn about how ONNX Runtime works, right, and in just a form of a simple code snippet, right? So in ONNX Runtime, how it works is, and this is a very, very basic general example to just show you how it works, but users like yourself can import the ONNX Runtime library into your code, and then start an inference session, which is a simple runtime call pointing to a model location. So like wherever your ONNX model is located, you can give that, you just point to that. And then you have to just provide some input data, and then ONNX Runtime will run the inferencing and generate the output. So now that you saw this code snippet of ONNX Runtime, now I'll show you how easy it is to use OpenVINO execution provider into your ONNX Runtime applications, right? So as you can see over here, it's just a simple modification to an existing line of code, right? So as you see over here, right, after you have installed OpenVINO execution provider, like I mentioned the installation options before, you can continue to import the ONNX Runtime library. But now with a simple modification to the inference session line of code, you can set the provider as OpenVINO execution provider, and you can utilize the power of OpenVINO within the ONNX Runtime API itself. So all it takes is just that simple modification to the line of code, right? And this example shows inferencing on CPU. To run inferencing on Intel iGPU or Myriad or VADM, please scan the QR code and learn how you can set the device type accordingly and run inferencing, right? All you have to do is just set a device type parameter and specify that that device, and then the inferencing will happen on that hardware platform. So that's all it is, right? So it's very simple, easy to use. All it is, it just takes this simple modification to your existing line of code. And yeah, that's it. That's all it takes. So if you have Intel hardware, right, if you are an ONNX developer and you are using any sort of Intel hardware, this won't hurt you, right? This will be a very easy way for you to just get accelerated performance for those models. Now that we have learned about what exactly OpenVINO execution provider for ONNX Runtime is, now let's look at some exciting demos. I'm going to hand the mic over to Preeta, who's going to show some exciting demos about some of the performance boosts we're getting. Right, we'll be showing some.
Excellent. We'll take this moment to remind people of our dear cat here in the studio. The cat tragically does not have a name. This is where you and the audience come in, or our guests as well. If you have suggestions for the name, please send suggestions to phil@opencv.org or newsletter@opencv.org, either one. It depends on how many people you want to see it. If you send it to phil@opencv.org, it only goes to me. We've gotten some great suggestions so far, but keep them coming. We haven't just, when things are named correctly, and we just haven't got the right one yet. So please help us out here. Back to the presentation. Whoops. All right.
We have some electrical problems in our studio.
It happens. It happens.
Awesome. So yeah, now that you know a lot more about OpenVINO execution provider for ONNX Runtime, and you guys have gotten an overview of this product and what exactly it does, right? So now let's look into some of the cool and exciting demos that Preeta has for us, right? Where we're going to see some of the performance boosts that you can get, and hope you can just follow along. There are some QR codes over there. I know folks are having some issues in scanning the QR codes. We'll give the links to some of these demos and samples that you can try out with yourself. But if that QR code is working for you, throughout the session while Preeta is presenting this demo, right? Follow along with her, and and try to see if you can see if you have whatever the performance boost that you can get with this product is.
Sounds fun.
So over to you, Preeta.
Thanks, Devang.
All right.
So yeah, now let's look at the demo for an object detection model. So here we see a NULO V4 inference being done with the CPU execution provider on the left and OpenVINO EP on the right. So you can see the performance improvement for yourself. So on the left of the CPU, we have like around 5 FPS, and for the OpenVINO EP, we have like approx 8 FPS.
So this is almost double. It's double the speed, essentially.
Almost, right.
Excellent.
And then we also have a cool demo for our quantization. So we have a feature for enable the quantization using the ONNX runtime EP. So we use, so on the left, we see the inferencing of an FP32 model ResNet 50 classification-based model on a CPU. And on the right, we see an int8 quantized ResNet 50 model. That's again like running inference on the native CPU. So here the quantization is done using our NNCF quantization. It uses the PTQ flow, which is still in like beta. But yeah, if you could see there, we saw a performance gain of around like 2x. So yeah, we see around like 5.8 ms for the CPFP32 model, and we see around like 2 ms for the int8 quantized model.
So
now let's look at the
over
accuracy,
2x
accuracy
fast,
trends.
then.
That's right. Now let's look at the accuracy trends. Are we losing any accuracy on the performance gains?
This is also a great video to show if your boss looks over your shoulder and you can want to tab over from YouTube.
So if we see the accuracy is around 76.3 for the FP32 model, and it's 76.1 for the int8 model. So it's very, very negligible loss in accuracy, but great performance gains, right?
Right. So here we have done two things, right? One is that the initial model was a CPU was a FP32 model, which means that all the weights and biases were stored in floating point, 32-bit floating point, and that model was converted using OpenVINO to int8 format. So it tries to preserve as much as possible, but you can see now the number of bits it uses for data is 8 bits instead of 32 bits. And then instead of using natively in ONNX, it's using the OpenVINO provider with ONNX. So there were two things done, and you can see that with those two things done, the performance, speed doubles without having any very negligible loss in accuracy, right?
Loss in accuracy. That's
excellent.
True.
As Satya said earlier, it's a free lunch.
It's a free lunch.
Sounds exciting, right? Now let's all like try to have some real hands on the samples. So if you don't have an access to an Intel hardware, it's pretty simple. You just have to head over to the Intel Dev Cloud for the Edge, a development sandbox for AI computer vision applications on the edge. So OpenVINO EP for ONNX runtime has a sample Jupyter notebook and containers that's readily available in Dev Cloud, where you can run the cells and see the performance boosts yourself for ONNX models on your preferred hardware, Intel hardwares. So a quick thing about the Dev Cloud is it has like instant global access, and we can like prototype to the we can prototype to the latest hardware and software, and we can like benchmark customized AI application on different frameworks, and we can like do all kind of analysis there, and it reduces like development time and cost.
Yeah, and this is it's an awesome system that for people that aren't familiar, it essentially gives you remote access to the real Intel hardware that you may not have available locally.
So this is our Dev Cloud marketplace where we have like really cool sample applications for almost all the products that we have that you can like quickly go try. So last week we saw about the OpenVINO integration with TensorFlow, which is also like really cool. And then we have our own sample for ONNX runtime, either for classification or for object detection. So let's go for object detection sample. All you have to do is just launch it. So it might take a minute or two. So this is where you can like select which is the hardware that you want. It can be the i3, i5, or the Xeon or Core i9. It's all electrically up to us. So let's go for a Xeon one with the Intel UHD graphics, integrated high graphics. This is the device that I'm selecting, and I'm just going to launch. That's all. Now I'll have my object detection sample that's queued. Meanwhile, while this is like getting queued, I'll also like to go through the Jupyter notebook that we have. So basically, we had a tab in the marketplace, right? Either we can like launch it or
edit.
We can like go, edit. So if we go there, I've just already loaded it, but it should be straightforward for you. We can just go to view or edit code, and here we have our object detection sample.
Sweet.
Basically, it takes like 3 arguments. You can like parse your input video and then like the ONNX model that you need, along with the device that you need to like run inference on. We have like support for all CPU, GPU, and then like the GPU FP16, VADM, Myriad, so on. Okay, and I'll show you the place where we have like. So if we give the CPU as a device, then it can run the CPU execution provider, which is the native ONNX runtime backend. So it will not use any of the OpenVINO stuffs. It's the direct default ONNX runtime. But if we don't provide the CPU, if we call it CPF32 or whatever the other options that we have, it will go to the OpenVINO execution provider. So this does all the magic. Now this handles the entire control of the graph to the OpenVINO toolkit, which will be able to run the entire inference of the ONNX model with the OpenVINO toolkit. This is all. Then rest we have all our post-processing and pre-processing stuffs. Now let's look at where our demo is. So for us to like go back, we can just need to go to the dashboard where we have like triggered the latest thing. So it's completed. It took around 50 seconds. Now let's look at our output. Yeah. So this is our input video. Now let's look at the demo. This predicts. Taken in a lab where people are wearing a bunny suit.
Obviously, this secret government footage that we shouldn't have access to.
From the movie?
Right. I think so.
Outbreak.
Secret. Yeah.
Cool.
This is like for 29 seconds, and we can also like have a preview of the performance, what we have, how much time it took.
Very cool.
So yeah, the total inference is like for 32.6 seconds, and the FPS is like 55 frames per second. We can like try for every possibility that we can like imagine for CPU, GPU, and then like with default ONNX runtime. It's a cool playground to actually play.
Yeah,
it's
incredibly
also
powerful.
It's also very
Yeah,
useful when you're trying to decide on the hardware for your final product. What kind of a device you want for your final product. Instead of buying each device and testing it out, you could easily try it out here to give you a very good idea.
Yeah, like buying or renting or borrowing whatever hardware. I know when I was with Occipital, there was a lot of sharing back and forth with various companies that had access to hardware that was really difficult to get, and it'd just be a sneaker net. Somebody put somebody on a bicycle and have them take it down the street. That's definitely a thing that used to happen. Yeah. So, do we have more presentation, or are we? Yeah.
We do have a quick slide on the
Excellent.
feature set that we have. We have like full of features. Now let's go over the feature set for OpenVINO EP. So it offers like multi-threaded inference, which enables like thread-safe deep learning inferences. And then we have like full support for OV plugins, native OV plugins, be it CPU, GPU, myriad, and hetero plugin, a single network on multiple preferred devices. Then we have like multi, which will like automatically assigns the info request to available computational devices to execute the request in parallel for improved efficiency. And then like we have auto plugins, which will automatically choose the hardware that gives the best boost for the given model to infer. And then we have our model cache, which will like enable the users to save and load the precompiled blobs directly. So they can just directly load these blobs onto the specific device hardware that they have, and inferencing can be done. It's supported for CPU, iGPU, myriad, VPX hardware device targets. And we have our model quantization, where we saw a cool demo, where int8 models are supported on CPU and GPU. Then we have this graph partitioning, like we discussed earlier, where many models, like including OD, object detection, like NLP, transformers, they all are like supported through the subgraph partitioning. So even if the entire graph is like not supported on OpenVINO, we don't need to worry. Even if it's like partially can be loaded on OpenVINO and then like partially on the native ONNX runtime. So even a minimal gain is still a gain, right? And then we have rates saved in external files, which supports the ONNX models that stores we can store the ONNX models in external files. This is it's very useful when the models are like very large, that is like 2 GB of size, and we have some protobuf limitations, right? So that's where this saving the weights in external files really comes handy. Then we have the majority of the OpenVINO ONNX operators are covered by the OpenVINO EP, and it has APIs for multiple languages like C, C++, or Python, C#. So whatever is your comfortable language, you can like really go for it. Then we have our IO buffer optimizations, which is again for enhancing the performance on, and following our like for more information, you can like look into these additional links. There are like really cool samples. Please do try out. Don't miss out all the fun.
As we wrap up the OpenVINO execution provider for ONNX runtime, I do want to talk about, what's next, right? What is...
Devang, can we pause for a little bit? There is a question we asked the audience so that
Sure.
they can win a prize.
Absolutely.
And I want to do it before 10 o'clock so that 10 o'clock
Please.
my time. And then we will have enough time to wrap up.
Sounds good. Sounds great.
Yeah, so one of the things we do every week here is a giveaway to you in the audience here in Zoom. I'm going to ask a question based on the presentation today, and the first person to answer that question correctly in the Zoom chat will win the OpenCV course of their choosing. If you have won in the last couple of months, please don't answer and give other people a chance to win. That's my rule. Nelson's Law. So earlier in the presentation, we discussed some of the Intel hardware that OpenVINO is highly optimized for. There's a new model of VPU out there. What is that called?
All right.
Oh, got it. Among Keem Bay was the answer we were looking for there. Way to go. Please send one email to phil@opencv.org, and we'll make sure you get your courses, and congratulations. We've also got a bunch of questions here, but I think we had a couple more slides. There you go.
Thanks a lot, Phil. And can I get my hands on an OpenCV AI kit as well?
Sure.
Thanks.
All you had to do was ask.
Awesome. Thanks. Awesome. So, if we, proceed now. So, right. So basically, I wanted to give a little bit of a sneak peek into what's next, right? This one is basically for all you PyTorch developers out there, right? We got so many questions asking if OpenVINO supports PyTorch models out of the box. And the answer is no, not currently. But we couldn't see unhappy faces out there when we communicated this to developers and customers, right? So we worked hard as a team to come up with a solution, and now we have officially released a product which is in beta preview, and it's called OpenVINO integration with Torch ORT. Okay, so what exactly is this OpenVINO integration with Torch ORT, right? So essentially, it's a product that accelerates performance of PyTorch models on Intel hardware with just 2 additional lines of code. So how it exactly works is that users can wrap their NN.module in the Torch ORT inference module, which actually prepares the module for inference using OpenVINO execution provider that we just discussed this product right now. And the module is actually exported to an in-memory graph using torch.onnx.export. So essentially behind the scenes, it's converting the model from PyTorch to ONNX. It's an inline model conversion. You don't see that from your eyes, but behind the scene, that's what's going on. And then an ONNX runtime session is started, and the ONNX graph is provided as an input. And then ONNX runtime will partition the graph into subgraphs with supported and unsupported operators. Like this is what the phenomenon we just talked about, which is subgraph partitioning. And all the OpenVINO compatible nodes will be executed by the OpenVINO execution provider and can execute on Intel CPUs, GPUs, or VPUs. And all the other nodes will fall back onto the default CPU MLAS execution provider. So the CPU MLAS execution provider will invoke ONNX runtime's own CPU kernels for nodes in the default operator set domain. So essentially, it's just 2 additional lines of code to your PyTorch application. Super easy to use. I'll just quickly show you, what we have as installation options for this product, right? But really, if you're a PyTorch developer, this would be really handy and helpful to you.
What is MLAS? Sorry,
MLAS is basically ONNX runtime. It's just another name for ONNX runtime. It's called MLAS.
Okay. Do you know the full form for it by any chance?
The full form, not 100% sure.
That's okay. We'll look it up later on.
Sure.
If anybody wants to guess in the chat, I'll send you an OpenCV sticker if it's funny.
Yeah. Sounds good. Cool. But yeah, so now how can you install it, right? Really simple. You can either go to our GitHub, which is, you can build from source, and this is upstreamed into the PyTorch/ORT repo. So you can just go and check this out, and you can build from source, and you get full access to Python APIs. You can also just do a simple and easy pip install. There is a pip install Torch ORT infer package, and you can get this installed onto your device. And I'll just quickly show you how PyTorch works and how and how we can use this OpenVINO integration with Torch ORT. So how PyTorch itself works is very basic application, right? This is basically what we can import is we can import Torch, and then we can basically this is importing PyTorch itself, the library, and then we can import Torch Vision.models as models, which is basically Torch Vision is another like sort of place where you can get access to a lot of models that are pre-trained, right? So over here, for example, for this application, we are using a pre-trained ResNet 50 model. And all we're doing is we're giving an input to the model, and we are doing prediction using PyTorch API. Now, if we look into how it works with OpenVINO integration with Torch ORT, right? Like I mentioned, 2 additional lines of code is better performance for your PyTorch models on Intel hardware. So the first line that's added is just an import statement, right? You import package the ORT inference module and OpenVINO provider options, which I'll talk to a little bit in the next slide. But basically, you'll import this from Torch ORT. And then the second line that's added is basically this ORT inference module that feed in the model to this, that prepares the model for inferencing using OpenVINO execution provider. So that's all it takes, just 2 lines of code, 2 additional lines of code to your PyTorch application, and you'll be able to see some great performance boost on Intel hardware.
That's great. And this ORT stands for OpenVINO runtime?
No, that is actually ONNX runtime.
Oh,
ORT is ONNX runtime. Yes.
Got it.
Yes.
Okay.
See, yes. I would have called it ORT.
ORT. Yeah. So, and that was showing inferencing on CPU, but if you want to do inferencing on Intel integrated GPU or VPU, you can always use the OpenVINO provider options, and you can set the backend as either GPU or VPU, and then you can run the inferencing on those target hardware. So yeah, that's overall, that was a brief overview. Hope you enjoyed the session about OpenVINO Execution Provider and a sneak peek into this this OpenVINO integration by TorchORT. I'll hand the mic back over to Phil, and maybe we can do some Q&A.
I definitely learned a lot during that presentation. I don't know about everybody else. It's one of those things that I love about this show is that pretty much every episode I hear 5 or 6 things I'd never heard before. So thanks so much for that, you two. We will now go to some questions. We've got a bunch of questions here from the audience.
Okay, am I audible now?
So Diego would like to know, can OpenVINO give is there any plans to have OpenVINO optimized ARM devices?
Yes, so we can. Basically, there is an ARM CPU device, ARM CPU plugin that's developed in order to enable deep neural network inference on ARM CPUs. So OpenVINO does currently can run and give a boost on this ARM CPU device.
Awesome.
Oh, that's
and
awesome.
and essentially, I think there's also.
I didn't know that.
And I've also came across a great blog that's actually from OpenCV. That actually talks about some of this ARM CPU plugin and how we even use OpenVINO. So,
and I probably edited that and I don't remember.
Yeah.
Thanks for that. Is there any potential loss in performance or accuracy by using these interchange formats like ONNX?
By using ONNX.
Yeah.
I wouldn't say
versus like native formats is what I mean. Yeah.
So usually, like what people say is like if you convert to ONNX, you can actually even get a little bit of a boost in performance for the models. And Preeta, you want to add anything to this?
Yeah, you're right, Devang. So basically, the native frameworks they are like enabled for training purposes, right? But deployment, when it comes to deployment, we train ones and we have like inferences on like the basic application is for inferencing, right? And this ONNX, it gives a better performance, at least for the most of the models, as it prunes most of the layers. There is, it's not like completely true for all the models. There is like potential gains in some, and there might be a minimal loss in the others, but generally it gives a good performance and the interoperability and the deployment, right? When it comes to the picture, ONNX is a go-to.
One other thing I actually personally would like to add that whenever we are changing from one format to the other, we should always check the accuracy on our test set, just to be on the safe side, right? It is a good practice because there could be a loss of accuracy, right? But there's a second reason for that. Let's say you're changing from FP32 to FP16. Okay, you got some boost, and let's say you did not lose any accuracy. In that case, maybe you want to go to int 8 to see whether int 8 is going to give you even faster execution and minimal loss of accuracy, right? So for those reasons, this thing should be done in steps, and we want to see how far we can push the speed while keeping the accuracy within tolerance.
I think it always makes sense to test. It's tedious, of course, but sometimes the tedious thing to do is the only right thing to do. It's the sometimes you have to read every paper. It's just the way it is. Yeah. So more questions here.
That's right. It also like varies from use case to use case.
Yeah. So Andre, let's see. It seems that ONNX supports dynamic shapes but not dynamic batch sizes. Is this true?
We do support like dynamic batch sizes, even like dynamic shaped models are now supported.
Great. Awesome.
We do have support for dynamic shaped models.
Thanks for that. We also have a few people that suggested what the full MLAS, what that stands for from earlier. Machine Learning Automated Service. That one's a little too standard. That's a C at best, Eli. My loss and shame. Now that one is way better. Little golf clap from my loss and shame. Golf clap for Zach, who said, "My last attempt, seriously." Also very good, very good.
Right. So thank you so much, Devang and Preeta. It was a fabulous presentation, and we learned a lot. Thanks for being here. And also, thank you, Phil, for organizing the weekly webinar. And finally, I want to thank all our audience. It means a lot to us. You guys show up here, encourage us. And so we are really grateful for this. Devang and Preeta, any last words?
Thanks for having us, Satya and Phil.
Thanks so much for appearing on the show.
Thanks so much for the opportunity, Satya and Phil. I think it was great chatting with you today, and hope everyone learned a lot from this presentation and gives it a shot, right? And just tries it out in their applications, and let us know any of the feedback that you guys have, right? You can connect with us on LinkedIn, or even you can reach out on and maybe post on the comments in the video that will be going out.
Yeah, definitely.
Thanks a lot.
This will be up on YouTube Monday morning as per usual. We will be back next week, of course, 9 a.m. Thursday Pacific time every single week. Hopefully still from this magnificent virtual set. Maybe with a name for the cat. Who knows? So far, we don't have one. Please send those suggestions to newsletter@opencv.org. I'm Phil Nelson, wishing you a pleasant day wherever you may be. Got to hit our outro. I need this for later.
Bye.
This is like my favorite part of the show. Yanni did such an awesome job with this. I love it. You get the cat in there, you get everything. It's beautiful. You really need to update this TV, though. I found it in the back. I don't know. All right. Take care out there, folks.
Bye, guys.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.